On March 15, 2017, I gave testimony before the Energy and Commerce's Subcommittee on Digital Commerce and Consumer Protection on the topic of graphene and attaining U.S. preeminence. 4 years later, I'm here to report that the future has arrived.
This hearing will come to order. Without objection, the chairman is authorized to declare recess at any time. Before I deliver my opening remarks, I wanted to note that today the committee is meeting virtually. I want to announce a couple of reminders to the members about the conduct of this hearing. First, members should keep their video feed on as long as they are present in the hearing. Members are responsible for their own microphones. Please also keep your microphones muted unless you are speaking. Finally, if members have documents they wish to submit for the record, please email them to the committee clerk, whose email address was circulated prior to the hearing. I now recognize myself for an opening statement. Good afternoon, and thank you to all of our witnesses who are joining us virtually today to discuss the importance of sustainable buildings research. This is a critical component of fighting the climate crisis. In my state of New York, we have some of the most densely populated cities in the country. We also have some of the most aggressive climate goals in the world. Thanks to a broad coalition of social movements, New York State passed the Climate Leadership and Community Protection Act in 2019. Part of this law was the inspiration for President Biden's Justice 40 initiative, which will channel 40% of the federal government's climate investments into marginalized communities. Also in 2019, New York City passed a first-of-its-kind law to cut greenhouse gas emissions from buildings. Now, we need to come together as a nation and build on these victories at the federal level. When we think of reducing emissions, we often think of renewable power or electrifying our transportation sector. But another large source of emissions, especially in New York, is buildings. Currently, about 40% of our country's carbon dioxide emissions comes from the structures that we live, work, and sleep in, and that we depend on for life-sustaining care. This goes to the heart of why we need to address climate change, inequality, and racism together. As we have been discussing on this committee, when climate disasters strike, red-line communities of color and low-income people are hit hardest. They're the first to lose power when the electricity grid is strained, as we saw in Texas, and these are the same communities that struggle with housing and utility costs. They face health risks from toxic materials in buildings, including in public housing that we have allowed to fall into a state of disrepair. In my district and around the country, the people who live in these buildings have been dying at higher rates from COVID, partly because of comorbidities caused by the fossil fuel economy. We need sustainable buildings now, and we need to rebuild our communities from the ground up. The Department of Energy invests millions of dollars every year in improving building technologies in a variety of ways. DOE, along with other federal science agencies, plays a role in making buildings more resilient to extreme weather. DOE also researches energy efficiency and increased electrification in buildings, with an emphasis on ensuring the equitable distribution of the effects of this clean energy research. Let's also think about how federal research can become more interdisciplinary. Social scientists, for example, have started exploring how green investments in neighborhoods can lead to gentrification. This process is not only unjust, but can undermine climate goals. Instead of cutting emissions for everyone, this can create a low-carbon economy for people with privilege while displacing communities of color and other low-income people out of dense, walkable neighborhoods. We need a combination of natural science, engineering, and social science to guide equitable and effective green investments for everyone. And research alone won't be enough. The other work that DOE must continue to focus on is how to get the results of this research into the hands of the communities that need it most. A week ago, I released a proposal to heal our K-12 school system from the impacts of climate change and the pandemic, and from decades of disinvestment. A huge part of this plan is focused on retrofitting public school buildings and removing toxic materials, beginning in the highest need districts. Schools can become living laboratories for the energy transition, putting students and young people at the center of the Green New Deal and launching STEM careers across the country. Big problems require big solutions, and that is exactly what we will be pursuing together on this committee. I am excited to chair the Energy Subcommittee this Congress and to hold this first subcommittee hearing on such an important topic. Investing in building technologies means investing in a safe, healthy future for our country and for the entire world. I want to thank our excellent panel of witnesses assembled today, and I look forward to hearing your testimony. With that, I yield back. The chair now recognizes Mr. Weber for an opening statement.
Well, thank you, Mr. Chairman. Welcome to the committee. We're going to have a little fun. We're going to be a lighthearted committee. We're going to be very serious about our work, serious about what we do with energy and for our country. So I appreciate you being here, Chairman Bowman. And thank you to all. My thanks I want to add to all the witnesses for being with us here virtually this afternoon. I will tell you that today we're going to discuss building technology research and development needs. And while I'm excited to hear about the critical work being performed by the Department of Energy's Building Technologies Office, and quite frankly, all across DOE, I want us all to be mindful of the role that industry can and should play in this area, especially where there is a clear incentive and an ability to take up mature technologies. I say this as someone who knows the building industry firsthand. In in the 1970s, I couldn't even spell air conditioning, or what we call AC in Texas. But by the mid 90s, I was actually running my own AC company. And I can tell you innovative material science, data analytics, and advanced sensors and controls, and private-public partnerships with these labs are exactly how we get the most bang for our taxpayers' buck when investing taxpayer dollars in this research. DOE partnerships with industry and academia enable the development of new technologies that can increase the energy efficiency of building envelopes, improve construction practices, and meet the demand for greater energy generation capacity. Today, we will hear from Dr. Jim Tour of Rice University in my home state of Texas, who will give us his perspective as one of those partners. As a professor of chemistry, along with material science and nanoengineering, Dr. Tour's research focuses on advanced building materials like, for example, lighter, stronger concrete that is a result of turning waste into a manufacturing additive called graphene. I look forward to hearing his testimony on how fundamental materials research can transform building technologies and how, at the same time, how successful public-private partnerships have supported these innovations. Just like Dr. Tour's example of turning trash into treasure, we can support a future that protects our environment for the next generation and is affordable for all Americans. But we won't necessarily accomplish this by doing what we call in Texas just throwing in the kitchen sink and billions of dollars at a broad, unspecified portfolio. Instead, we should make our clean technology affordable through significant investment in fundamental research paired with targeted and responsible investments in applied energy R&D. That is why this week I was proud to sign as one of the original co-sponsor of Ranking Member Lucas's Securing American Leadership in Science and Technology Act. This legislation supports a diverse, all of the above clean energy strategy and prioritizes critical research to establish U.S. leadership in industries of the future like advanced materials and manufacturing. This long-term strategy for investment in basic research and infrastructure is how we in Congress should support innovative building technologies. It creates a pipeline from lab to market and is the most direct and efficient path to a more sustainable future for both new and current buildings. Thanks to the witnesses. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Weber. The chair now recognizes the chairwoman of the full committee, Ms. Johnson, for an opening statement. If Ms. Johnson is not present at this time, the chair is going to move forward. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Dr. Nora Ezram is the Senior Director for Research of the American Council for an Energy Efficient Economy. Dr. Ezram oversees ACEE's research programs on buildings, transportation, industry, and behavior. Dr. Ezram holds a PhD in architecture from the University of Illinois, Urbana-Champaign, and is a licensed architect. Dr. Roderick Jackson is the Laboratory Program Manager for Buildings Research at the National Renewable Energy Laboratory. His portfolio includes a broad range of research, development, and market implementation activities that aim to improve the energy efficiency of buildings, materials, and practices. He holds a bachelor's, master's, and PhD in mechanical engineering from the Georgia Institute of Technology. Dr. James Torr is a TT and W.F. Chao Professor of Chemistry, Professor of Computer Science, and Professor of Materials Science and Nanoengineering at Rice University. He received his bachelor's degree from Syracuse University and his PhD in chemistry from Purdue University. Ms. Jacqueline Patterson is the Director of the NAACP Environmental and Climate Justice Program. She has worked as a researcher, program manager, coordinator, advocate, and activist working on women's rights, violence against women, HIV and AIDS, racial justice, economic justice, and environmental and climate justice. She received her master's degree in social work from the University of Maryland and a master's degree in public health from Johns Hopkins University. Last but certainly not least, Mr. Joseph Hagerman is a section head for buildings technology research at Oak Ridge National Laboratory. He leads the lab's research in building envelope materials and equipment, as well as in integrated building performance and multifunctional equipment integration. He holds a master's in civil engineering from the Fu Foundation School of Engineering and Applied Science at Columbia University and earned his bachelor's in architecture from Mississippi State University. Thank you all for joining us today. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you all have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. Dr. Torr, you are now recognized.
Thank you, Mr. Chairman. I'm a professor of chemistry, material science, and nanoengineering at Rice University and part of the Welch Institute for Advanced Materials. I have 730 research publications, 234 of those on the topic of graphene. I have over 50 US patents plus 90 international patents on graphene. In the past 6 years alone, my academic research has led to the formation of 14 companies, 8 of those in nanomaterials, and 2 of them now public companies. On March 15, 2017, I gave testimony before the Energy and Commerce's Subcommittee on Digital Commerce and Consumer Protection on the topic of graphene and attaining US preeminence. 4 years later, I'm here to report that the future has arrived. What is graphene? Think of it as carbon chicken wire. That's what it looks like. Chicken wire in its atomic arrangement, but on the 1 atom thick scale. Graphene is a non-toxic, naturally occurring carbon material, and its agglomerates are the natural mineral graphite. It is very slow to enter the carbon dioxide cycle, and hence it can be considered a terminal carbon sink with near zero contribution to greenhouse gas emissions. Graphene is a revolutionary material for building construction, but until recently, affordability and access to sufficient quantities made it only a dream for those applications. In 2018, a graduate student in my laboratory, Due Long, working under funding from the Air Force Office of Scientific Research, discovered a process that we call flash graphene. We immediately filed patents to protect the technology, and companies were formed 1 year later, Universal Matter Inc. and Universal Matter Limited. The process can take any carbon material, and convert it into graphene in less than 1 second, using only electricity, no water, no solvents, no additives other than carbon itself. This new graphene manufacturing process will lower the cost by a factor of 10, therefore making it economically viable for use in building materials. The majority of waste products generated by human beings are carbon-based. If it's not rocks or water, it's probably carbon. We can take coal, petroleum coke, unsorted plastic waste, discarded food, mixed household waste, any other carbon source and convert it into graphene. Our production rate is doubling every 9 weeks, thereby projecting to hundreds of tons per day scale within 3 years. With grants from the Department of Energy and Department of Defense and collaborations with the Army Corps of Engineers, ERDIC, Argonne National Laboratory, and several large automotive, concrete, asphalt, and wood manufacturers, we're developing graphene for concrete, asphalt, aluminum, plastics, polymer foams, lubricants, rubber, wood, fabric, and paint composites. By adding just 0.1 weight percent, that's 0.1 weight percent to cement, we get a 35% enhancement in compressive strength. It means we could use 1/3 less cement for construction. And since cement and concrete constitute 8% of all worldwide carbon dioxide emissions, that could translate into a remarkable diminution of emissions. Concrete alone is a $30 billion new market opportunity for graphene. 0.5 weight percent addition of graphene to asphalt will triple the life of the road. 0.05 weight percent of graphene to carbon fiber composites will lower the weight of an aircraft by 20%, translating into enormous fuel and carbon dioxide reductions, all made possible by this U.S. invention. Through Rice University's Carbon Hub, we're developing methods to convert natural gas into hydrogen and graphene with near zero carbon dioxide emissions. That's clean hydrogen fuel from natural gas. The next step is to develop entirely new classes of graphene that can substitute for the energy-intensive 2,500-year-old materials that we use today, like concrete and steel, while providing a non-toxic carbon sink for most human waste products. The takeaway from my testimony is this. First, continue to foster basic support of basic and applied research directed toward advancement and deployment of new materials. A few years ago, graphene was only viewed as appropriate for ultra-high-end aerospace and device applications, but not anymore. The bipartisan Endless Frontier Act could embody an interesting approach to achieve the requisite research and translational goals. Second, it remains challenging to go from the lab bench to the build site with market profitability. Congress has immense power and influence over tax policy and administrative and regulatory burdens that can make or break our startup companies. Third and finally, streamlining the green card process for scientists and engineers that have received their PhDs in the U.S. so that people like Dewey Long, the Vietnamese graduate student that discovered the flash graphene process in my laboratory, can stay to develop their discoveries in our nation's companies. We just need to do it right, safeguarding U.S. intellectual property through background checks and security oversight. Thank you.
Thank you, Dr. Tor. I now recognize Mr. Weber for 5 minutes.
Thank you, Mr. Chairman. I want to go to you, Dr. Tour. I want to make sure that what I think I heard. Are you with us, Dr. Tour?
I am.
Okay, good. You've got 730 publications. 230 of those were on graphene. And there was how many patents and how many companies formed as a result?
I have over 150 patent families, but 50 U.S. on graphene and 90 international on graphene. Started 14 companies, 8 of those in nanomaterials. Thank you for that. You said a decade ago, your program was supported by 90% by federal funds and then 10% by industry, and that was normal for many research groups. Then, due to a number of factors, you started appealing to industry and showing them how your fundamental research in nanoscience could address some of their technical needs. And boy, the numbers you just reiterated for us, if they don't prove that you were successful, I don't know what does. Yeah. This might surprise some people who think industry only wants applied research. So, Dr. Tour, can you talk more about basic research, how it can deliver applications for industry, and specifically in the building technology sector, please? Right. So thank you for that, Representative Weber. So what happens is I do basic research. I'm a scientist primarily, and but the transition is something that we need to look for. How do I transition this into something that can be applied and utilized? And when we make discoveries, right away we need to be thinking, how can I apply this? And if we just publish a paper and just think somebody else will apply it, it just doesn't work. We need to carry that banner several more steps forward to show them how it might work. I don't have to bring it all the way to the building, but I have to bring it to a point where some company is really interested. So for many years, we would license our technology to big companies, and for one reason or another, it would stall in those big companies. So about 6 years ago, I made a categorical decision. We are going to start our own companies. And we're going to start our own companies and build upon those, because then we can control the technology and push it forward. And success breeds success. After we were successful with one or two, then investors started coming and wanting to fund more and more. And part of that is, I say, you've got to continue to fund some of the basic work in my laboratory that will broaden the applications of these, and that then spawns new companies. So that's basically how we've done it.
Well, and that's a great segue, because when you talk about broadening it and spawning new companies, as you know, as a Texan, Houston is an active hub for oil and gas industry, and also the aerospace industry. And so these large industries have become interested in your work, and can you explain that, why many of the quote building technologies end quote research projects have applicability actually to more than just the skyscraper construction business? What other abilities does it have?
Well, it has to do with roads as well as concrete for building, with paints for wood composites. Everything is about lightweighting and using less materials. And when we use less materials, there's less carbon dioxide emissions, less energy put into them. And the processes that we've come up with, so for example, just plastic, just high density polyethylene is $2,000 a ton. We put in $30 a ton to convert waste plastic into graphene that can strengthen a huge amount of plastic with that. So these innovations have great implications for the energy industry and for lowering carbon emissions.
Sure, you betcha. Well, I'm just about out of time, so I will go ahead and yield back, Mr. Chairman. Thank you for your indulgence.
Ranking Member Lucas is next.
Thank you, Mr. Chairman. I want to thank you and the ranking member. This is a fascinating hearing and some really impressive witnesses today. With that, Dr. Tour, I'd like to turn to you and note that the Securing American Leadership in Science and Technology Act, SALSTA as a lot of us like to refer to it, creates a long-term strategy for investment in basic research and infrastructure to ensure American competitiveness in industries of the future. So with that, I turn to you. In your testimony, you noted that you or your companies have received grants from both the Department of Energy and the Department of Defense, and you've also collaborated with the Army Corps of Engineers. Having worked with different agencies, do you think a more coherent government-wide strategy on federal science and research efforts could assist federal agencies and the national laboratories in being a more effective partner to researchers?
Yes, absolutely. Anything that can be done to assist these interactions where we can work across, because the national labs have tremendous facilities that we at universities would love to be able to access. And working with the national labs has been terrific. I mean, we have representatives here today from Oak Ridge. We've published papers just recently with Oak Ridge, and we're doing more. And so to facilitate this, and then it's not just, then it goes from me to then the companies. The companies are able to work. And so we have both me at Rice University and the companies working with the Army Corps of Engineers. The company is doing much bigger projects. We're doing the nano-sized projects, so they're doing the macroscopic projects, but all working toward the same direction. So whatever Congress could do to streamline that would be terrific.
And how do you think such a strategy would impact international competitiveness in next generation technologies like building efficiency?
So one of the things that we have done in the past, because we didn't have access in the university to certain equipment, is we've established collaborations with overseas universities. And that's a shame. I mean, if we could keep it all here in the United States, that would be much better. And this has to do with the nanomaterials that are going to go into making building materials with a lot less footprint of energy. Like I said, concrete and cement, 8% of all CO2 emissions. If we can lower that, it is tremendous. And then the jobs, then it all affects right here. So it would be very good if we could streamline that and have to be less dependent on the excellent access to equipment, particularly in Asia.
Dr. Tour, our legislation I mentioned, SALSTA, also aims to expand our American STEM workforce pipeline and its investment in infrastructure needed to maintain domestic research facilities. So I'd ask you the following. What role does infrastructure, and by that I mean world-class laboratories, top-notch instruments, collaborative user facilities, have in attracting and keeping researchers here in the United States?
This is a very big deal. We have a brain drain going on right now because students are going back to their home countries rather than becoming professors in the US, which they have traditionally done, because of the lack of equipment and the lack of deep support from government agencies toward academic research. And they are going home because the packages they can get are much better. I've testified to Congress before on this same issue, that the brain drain that is currently happening in the United States is frightening. Many of these people would have stayed in the US had the packages been here, had the equipment been here. So if we want to keep the first class people here, we've got to have the infrastructure to maintain this.
Mr. Baird is next if he's available.
I am.
You may proceed.
Thank you, sir. You know, I really appreciate your having this hearing, Mr. Chairman and Ranking Member Weber. And I see our Ranking Member Lucas is on here too, and he's always got an interesting perspective. But the thing that I was very interested in, Dr. Tour, I'm going to start with you because I found this carbon sink and the materials you mentioned kind of fascinating. And, you know, we have a tremendous capability at DOE with the computer capacity we have to be able to advance this kind of technology. So I hope we can see a strong future partnership between the industry and our national labs and all this kind of research. But I would just like for you to elaborate on, you know, using the material to make cement, airplanes, building materials, and how we get that to our rural communities and some of our more remote situations. So that's the question.
Yeah. So thank you, Representative Baird. This is a real material that is transforming right now. So like I said, our production rate is doubling every 9 weeks. So a single factory within 3 years will be able to produce hundreds of tons of this per day in about 3 years. And that's the projection rate. The collaborations right now are happening with companies that are testing these in concrete and asphalt. And one of those entities is the Army Corps of Engineers, ERDEC in Mississippi, because they have the capability to do this. And then there's agreements with companies. We're working with big auto manufacturers taking their waste plastic because they're responsible now, at least overseas. They're responsible, the American companies that sell overseas are responsible for their plastic in the EU now from every vehicle. And it's almost 200 kilograms of plastic in a car. We've converted that into graphene. We've given it back to them. They put it into new plastic that goes into cars. So it's really a wonderful cycle here. And the energy savings are real material. This is real material going into then construction, concrete, wood composites with wood manufacturing. So this is really beginning to transform this. And this is one of the things that's been permitted by keeping this in a small company where I can help to control this and say, no, we got to get these into these products, as well as small companies contacting me that want to deploy this. I say, okay, we're not in the big scale deploying right now, but that's going to come within a few years. And we mark down their names, and we want to see this deployed.
Fantastic. I find that extremely interesting, you know, and then with the ag background, some of the materials that you could have access to, including forest products, that be converted into this kind of material is of great interest to me. So I'm glad to see the research that we do, the research that you've done, making that kind of progress. If any of the other witnesses would like to or care to make a comment, feel free to do so at this time. I've got about a minute and 25 seconds left.
Mr. Garcia is next.
Thank you, Mr. Chairman. Chair Bowman and Ranking Member Weber, thanks for pulling this together. This is actually very interesting discussions here. I want to thank all of our guests and actually congratulate you all for your achievements and your successes being leaders in your respective fields. I've got two questions. The first is for Dr. Tour, and the second is for Dr. Jackson. Dr. Tour, this graphene discussion is very interesting. When I saw the write-ups for this, I was doing some homework yesterday in preparation for today, and what I was looking at initially was whether or not the use of graphene would become a potential environmental risk, like what we've seen with PFAS in creeping into our water tables. I'm sure you're familiar with what PFAS is, the polyfluoroalkyl substances. We have a contamination problem in California with PFAS getting into our waters, and while I was doing that research, I was reading that graphene is actually, as it's a, you know, it is effectively an allotrope of carbon, right? It's a derivative of sort of an activated carbon. And I was reading articles where graphene may actually be used to remove PFAS as a potential filtrate opportunity. Have you seen any research or done any research to where the use of graphene within water filtration systems can help mitigate our PFAS problems that we're seeing in some of our local communities?
Yeah, I don't know particularly with PFAS, but I know that graphene, these carbon materials, are indeed being used for water filtration. In fact, I have a company that's actually doing that, using graphene in water filtration systems, and the thing about graphene is it's already natural in a riverbed. It's shearing off slices of graphene. It's already naturally occurring, and that's what makes it all the more attractive, in that it's a naturally occurring material, hard to access, but for water filtration, the PFAS problem, there are other ways that we're addressing that, and actually my group is addressing particularly that problem. So I know something about that, and we've just recently gotten some grant money to do that through the Department of Defense to try to address specifically that PFAS problem.
If it's okay, I'd like for maybe you and I can take it offline, but I'd love to connect you with our local water districts here in my district in Southern California. They're struggling with this right now, as many are, but they're on the precipice of making very significant investments, and I'd rather make sure, I just want to ensure they're looking at all options before we go too far down range. A lot of federal assistance going into this type of program as well, as you know. So I would love to be able to connect you offline if we can with some of our folks on our end.
Be glad to.
Thank you, sir.
Thank you very much. Before we bring the hearing to a close, I want to thank our witnesses for testifying before the committee today. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. The witnesses are excused, and the hearing is now brought to a close. We are adjourned.